Hello everyone, welcome back. In today's video, we are diving into an important concept in operating system, how the process are managed by the operating system. In today's video, we will be covering what is a process control block and why it is important, how the OS manages memory using process address space, and then how those processes are uniquely identified using process identification. By the end of this video, you will understand how the OS keeps track of processes efficiently. So let us get started. Firstly, we have to know what is a process control block. Think of it like this: a process control block or PCB is like an identity card for a process. Like for you, an Aadhaar card is your identity card. So, for a process control block is an identity card. It's a data structure used by OS to store important details about a process. Whenever a process is created, the OS assigns it a PCB to keep track of it. But what does the PCB contains? You have to know about that too. So in the PCB, there are several fields of information about a process. The first one, the most important, is process ID. It is a unique number assigned to each process. Then we have the process state or the current state. It tells the state that it is currently in. We have learned about all the five states in the previous lecture, that is new, ready, running, blocked, or terminated. After that, we have CPU registers. It stores value of CPU registers when a process is paused. Then we have program counter. Okay, program counter means the used by for the next instruction the process will execute. And then memory information. The memory information contains the location of process code, data, and stack in RAM. After that, we have IO information. It contains the details about open files and devices used by the process. After that, we have priority. It contains the how the process gets CPU times, whether it will be in a priority state or a normal state. Okay, think of it the PCB like a student record for a university. The student ID is the process ID. The class schedule is the program counter because the next instruction it contains the next instruction the process will execute. Then the grades and progress are like the process state. Then each process must have a PCB, and when a process terminates, its PCB is deleted. So the lifetime of a PCB is from the creation of a process to the termination of that process. Now, coming on to process address space, every process needs some memory to store code, data, or variable. The operating system manages this by using process address space. So, what is a process address space? It's the range of memory address assigned to a process. Each process has its own address space to prevent interference with other processes. If we look at the structure of the process address space, we have four things. The main important thing is text section. As the name suggests, it contains the program code and is in only read mode. You cannot modify it. Then we have the data section. It means that it stores the global and static variables. After that, we have the heap section. Heap section stores dynamically allocated memory, that is, memory allocated using malloc in C. I hope you have all used malloc in C for memory allocation. Yeah. So then we have the stack section. A stack section stores function calls, local variables, or any written addresses that it might contain. Now let me give you an example. So whenever you use Python, the code is in the text section, global variables are in the data section. When you use input, that the memory is allocated in the heap and the function call goes into the stack. The operating system always ensures that the memory is used efficiently, and also it prevents processes from accessing each other's address space for security. I hope you learned about the process address space clearly. If you have any questions regarding process address space, you can leave it in the comment. Now, going further, we will look at process identification information. So, the operating system it needs to uniquely identify each process to manage them efficiently. This is done using the process identification information. Firstly, we have process ID that we have learned some time ago. Every process gets a unique PID assigned by the operating system. It helps the OS track and manage each process separately. Then we have the parent process ID. Every process is created by another process called its parent process. The PPID helps track the relationship between the process. For example, if a process is large, then there may be some sub-processes that are created. Those are child processes or the program ID, but those parents will called parent processes and they will contain parent process ID, and it is used to track the relationship between the process. For example, when you open a terminal and run a program, then the terminal is the parent process, the program is the child process, and the OS assigns a unique PID to the parent process and PID, that is to the program ID to the child process. After that, we have user ID and group ID. That is UID and GID, you can say. It is used in multi-user system to identify the owner of a process. It ensures security by restricting process access based on user permission. It means that the security is contained and it will allow only based on user permission. Then we have the process priority. It determines which process gets CPU time first. It means that higher priority equals to faster execution. An example of this is a real-time video call app will be higher priority than a file downloaded in the background. So, whenever you download a file and you are on a video call, so you might have noticed that the speed of the downloading is decreased. Yes, and that is for the process priority. At that time process priority is used, so the OS manages hundreds of programs at once. So proper identification is crucial for the smooth operation, because otherwise the system will get chaotic or it will crash the system. Now moving further, we will look at the summary and conclusion. So far we have learned about process control block. It stores process details like state, memory, and IO info. Then we have the process address space. It divides into text, data, heap, and stack sections. Then we have the process identification. It uses process IDs, parent process IDs, UIDs, and priority level to track that current process. Okay, so understanding these concepts, it will help us how to see how an operating system efficiently manage any process. Okay, so if you found this video helpful, don't forget to like, subscribe, and comment below. See you in the next video. Thank you.